Fortunately for you guys, I'm going to be teaching you how to build a robot, not how to do the robot. And while explaining, I will reference three main topics. These three main topics are brainstorming, assembly, and knowledge, which is the most important thing. So to begin, I will start talking about brainstorming. And there's a story behind brainstorming. Every year, we go to Vex Worlds, or when we're lucky, we go to Vex Worlds. And at Vex Worlds, the new game reveal happens for Vex Robotics. Vex Robotics is a competition that we, as Abraham Lincoln, participate in. And so we try to do our best and show off our school's talent. So at Robotics last year, the game was revealed, Starstruck, and when the game is revealed, we instantly start thinking of what the most optimal robot design is. And so we have a few brainstorm ideas ourselves, which are not quite final drafts like Chippy himself here. So a few of the constraints that Vex applies to us is we have to have a robot that starts in an 18 by 18 by 18 cube, which is 1.5 by 1.5 by 1.5 at the beginning of the game, but after the game starts, it can expand, which is what I will show you here. During this game, the objective is to throw cubes and stars, which are really awkward objects, over a giant fence that divides one alliance from another alliance. And the team that has the most objects on their side loses. So we wanted to build this robot with a giant claw, and so when it flipped out, it would be able to pick up tons of objects. It was not quite this advanced at the beginning. We had a few ideas that were not the greatest, but thanks to China, we compared our ideas to them, and then we made a few ideas of our own. We have a seasonal advantage where our season doesn't start until after Singapore's and China's do, so that's lucky. But moving on to the actual assembly of the robot, we in robotics, we break it down into three different segments. We have the drivetrain, which is sort of the car that drives the robot around. We have the lift, which is this thing here that will lift game objects. And then we have the intake, which in this case is a claw. I didn't say it earlier, but there's another constraint that we have is we are only allowed to use either 10 motors and pneumatics or 12 motors on our robot. And this year we decided to use 10 motors and pneumatics. So we have 6 on our drivetrain, 4 on our lift, and then we have pneumatics on our intake, which is an air pressure system. The air pressure system, we use a bike pump to pump into these reservoirs, and then they're tubed throughout the robot and pushed through a solenoid, which programs our robot. When we push a button, it will cause the contraction of these pistons or the extension of pistons. So the drivetrain is 6 motors, and it's geared internally for speed. So the regular motors are not quite fast enough for what we wanted, so we had to buy special motors that are internally geared for 2.4 to 1, which means they are 2.4 times as fast as regular motors. Moving on to the lift, we have internally geared slightly faster than the regular motors, so they're 1.6 to 1, which means they're 1.6 times as fast. But we run a gear ratio from our lift 1 to 7, but you usually divide 7 by 1.5, which makes our total gear ratio on our lift 1 to 4.375. Now this may just seem like a bunch of numbers to you guys, but it basically means that our lift is 4.375 times stronger than it would be if we just put 1-to-1 gears. And then our claw, we wanted to have a snap to it, so we use this air pressure system, and plus we look a lot cooler than everyone else who's just using regular motors. So we have this awesome snap that spreads out stars when we throw them over. You might be thinking, this is all cool information, but when am I ever going to build a robot? So why is this information good? Well, this benefits society in a way that's sort of indirect. There's a lot of lessons that you learn from building a robot, and that's why companies like PLTW and Vex are trying to extend into younger age kids like middle schoolers and give them opportunities like Vex IQ, which is sort of like Vex, but it's with plastic parts and smaller robots that also have a world competition. But indirectly you learn a lot of things, and it's a lot of real-life application that you wouldn't get in your regular classes. So, as a recap, today I talked about the brainstorming process that we go through. We talked about a few components of the robots during the assembly, and we talked about some of the things that you can learn and benefit from. So, domo arigato.